this basic while loop, how does it work, and maybe why do we need it, right? So I'm going to do some short videos on these things. That's why you are seeing this number 8. It is supposed to be video number 8. So you're going to see these videos later, but for you, let's just basically look at these things as we are now in the lecture. So we are going to do a while loop. So now let's look at what is a while loop. Maybe how does it work? So this one, this thing that we call a while loop, is just a control block which actually repeats the code, as long as a condition is true. So you'll be having a condition there. This is what I was saying. So you have a condition like this one. We have a condition here, while then condition and then a block of code. So what does it do? It keep on or repeats the code as long as this condition is true. So that's what this while loop does, right? For example, here we can have this int I is equal to 1, and then where I is less than or equal to 5. What does it do? It is going to keep on printing this. Let me just have a highlighter. So it is going to keep on printing. Let me change this color, maybe something like green here. So it is just keep on going to, it is going to print this as long as I is less than or equal to 5, something like that. So this one is very, very useful whenever you have a code that you want to be executed, maybe for some time there. So instead of keep on writing that code, you could just put it in a loop, and then it will be executed for some time that you want it to be executed, rather than keep on writing. So here we are just supposed to do a quick demo on this while loop. We just need to do a quick demo on this while loop. So first thing first, you need to include, let's include the stdio.h file. And then what do you need to do there is to have maybe the main method or the main function. Guys, you cannot write a C program without putting the main function there. Why? Because that's where the program execution actually starts. So you need that thing. So you can have maybe int I. Let's initialize it to 1, right? So I forgot to put the I here. So what are we supposed to do here? Maybe you want to say, well, then you put the condition there. Let me first put the return 0 here. This statement is also very, very important. Okay, so what am I supposed to do here? I want to print like this, printf. All right. I want to print, maybe let me just print I here. Nothing much here. Let me just print. Okay, I want to print the value of I. Then let me put %d there, and then I'll put I here. Or I can just put %d and put an I there. And then since here I want the condition to be while I is less than maybe or equal to 5. So I'm going to print the value of I from 1 until I is less than or equal to 5. So if you do not put a condition that makes, or a code that can make this condition false after some time, then this will become an endless loop. In an endless loop now, it will become a loop that will be keep on executing without terminating. So to avoid endless loops, please make sure that before testing your code, you are sure that the loop is going to end. So this one, as of now, it's an endless loop. Why? Because it is going to check, is it I or is it 1 less than or equal to 5? Yes, they need to print this. Then it will come back here. Is it 1 less than or equal to 5? So there's nothing here which is changing the value of I. So how do you do that? You need to put maybe I plus plus This means that we are going to increment I by the, or you can say I is equal to I plus 1 to make it easier for others who were not in the lecture last time. We've talked about the I plus plus is as good as I is equal to I plus 1. So what does this mean is that whenever you print this one, then you increment the value of I by 1, then you check, you print, you increment the value of I by 1. So if I compile and execute this, compile and run, I'm going to get that. Can you make sure that we are always on mute? I'm getting a feedback. Let's make sure that we are always on mute, guys. Thank you for that. These are the simple rules that I've said before. So I'm getting the value of I is equals to 1, the value of I is equal to 2. Okay, I forgot to put this precious thing. Let me just put the slash n here to write the next thing on a new line. Oh, this, I need the compare and run. So I'm going to get the value of I is equal to 1, the value of I 2, it was supposed to be equal to 1, whatever. So it's from 1 up to 5. If you look at it, so I'm printing the value of I from I is equal to 1 until I is equal to 5. How is this happening, right? So if I asked you to print 1 to 5, maybe you're supposed to write print 1, print F, then you put it 2, print F, you put it 3, until you reach 5. So instead of doing that, you can just have this symbol, this symbol 4 lines doing that job for us, right? So this loop is just checking at first, is it at first I is equal to 1, so is it 1 less than or equal to 5? Yes, so print 1 and then increment I by 1, so you have a 2. So 2 is less than or equal to 5? Yes, print 2, then increment I by 1, then you have a 3. 3 is less than or equal to 5? Yes, print 3, then increment I by 1, then you have an I as 4. 4 is less than or equal to 5? Yes, print something like that, print 4, then increment by 1, then you have a 5. 5 is less than or equal to 5? Yes, so print 5, increment by 1, then you have a 6. Is it 6 less than or equal to 5? No, so it will jump out of a while loop and then it will start to execute whatever just after this while loop. So here, if I put something here, you could find out that as soon as it as the condition gets to false, it will jump out of that while loop and do whatever comes next. So here I can just say maybe out of while loop. So here that's after. Let me just put a slash n there to skip a line. So after it have executed and printing all these values, let me just put I there. Let me just put, so here I'm just going to print 1 to 5. Let me allow this one to join. So if I run this, I'm going to get 1, 2, 3, 4, 5, and then I'll get out of while loop. Just as simple as that. So that's how you make use of a while loop, and you can use this while loop whenever you do not know how many times or how many exact time that you need that code to be executed, but you know that after this condition, then my code will be good, or whatever you want to solve will be actually been solved. Then you can use this while loop and you model your condition so that maybe if you want it to run for some time that you do not know, like here, we do not know, maybe we just want to run exact 2 times or exact 5 times, but what we know is after executing it for 5 times, the result that we get will be good for us, something like that. So that's where you can use a while loop. Right? Or maybe you can ask someone to enter the password and you put them in a loop, and if they does so if they do 3 attempts being while they are putting the wrong password, and then maybe you can block their account, or maybe something like that. That's how you can use a while loop, or you can just force them to exit the the code, maybe by jumping to some code or by just exiting the code or returning to 0 there, and then everything will be terminated, something like that. So that's how you use a while loop. I don't know if I've got questions, but if I do not have questions, let's look at a do while loop, which is just a variant of a while loop. It's just like the same as this while loop that we already have covered, but this one now it actually executes the code first before checking. It executes the code first before checking the condition. So you do some work and then you check the condition later, something like that. That's the do while loop. So on this do while loop, it's not a while loop. It was supposed to be what is a do while loop. So similar to while loop, but this one now it executes the code at least once, something like that. So you are sure that the code that you have inside this block, this code which will be inside this block, is going to be executed at least once, right? It's now different from the while loop where the condition is actually first checked, and it actually is supposed to give you a true. So while the condition is true, then it will do something. But here we are saying, do this task and then later check on the condition. So you might want to do so, like here we've got this one, which actually first print the value of I and increment I, and then check if I is less than or equal to 5, something like that. So it's as good as do something, then check the condition later, something like that. So there are scenarios that you might want to use such kind of code. So instead of having a while here, you just need to take it out and have a do. So this do this whole code, and then let me just put it here, and then check the condition later, and you are supposed to terminate this one. So you are supposed to terminate the while condition there. You need to take
Hello,
the
sir.
yes, yes, yes,
Hello, sir.
yes.
Okay, I'm trying also to do it on my machine while you are speaking, eh? And then mine is not giving me like 1, 2, 3, 4, 5. It's giving me, oh, I don't know, maybe I messed up somewhere. It is giving me some large numbers, but with the like the first value out of, because I did the output for the program, the I'm using code block. I'm using code block. So the output of it is showing me some value like I 1, 3 something big, some big numbers, but it is showing the output though.
Okay. If
I don't
you
know where would have messed up there.
if you okay, on your printf here, you need
Yes.
to look you need to look at your printf. If you used the right format specifier here, like %d,
Yes, I did use %d.
and then if you put this I, just I, without putting the address operator here, this one.
Okay, let me cross check. Okay, I think I did something like that.
So you are not supposed to put an address operator here.
Okay. Oh, I think I saw my problem because I put that exclamation, those semicolon, those semicolon after the I. I think that's where the problem is.
Okay, okay, okay.
Yes.
So
Let me just check and then see if it runs properly.
okay, it's okay.
Yeah, it's now fine. It's now fine.
Okay, so that's what you need to actually look at. So normally when you're doing program, it's not magic. It's not magic. You just need to understand the language, understand the basics, and then you are good to go. Like here, I know if you have done it correctly, we know what the printf wants. It needs this double quotes first, and then you put a comma, you put variables that you want to print. If I was going to print maybe 3 variables, you separate them by a comma. Like here, if I've got int I, maybe I've got b here, b equal to 5, maybe I have a c here, b equal to 6, something like this, right? So if I want to print all these 1, 2, 3, 4 variables. I also need to put maybe these format specifiers, maybe these 4 format specifiers. And then what can I do now? I need to put this B, this C, something like this. So 1, 2, 3. So it was supposed to be 3, not 4, something like this. So what it means is that it is going to match this with this I. So this one is just a placeholder here, and it is going to match this B with this, and then this with this, something like that. So you just need to know the basics. So if I execute this one, obvious 5 and 6 are going to be repeated. So it is going to print 1, 5, 6, 2, 5, 6, 3, 5, 6. Why? Because I am not changing, or I'm not modifying the values of B and C. I'm only changing the value of what? Of I, something like that. So if you bump into an error, the best thing is, okay, so this one might be coming from a printf. So how can I fix it? You go and look at how are you, or how can you use the printf to print or to print whatever you want to print to the user, and then that one will help you to have an easy fix on your code. Okay, thank you for that. So here we are looking at a do while loop. So I was saying with a do while loop, we are saying do this task first and then check the condition later. This one you can use it maybe if you are being asked to do a menu based where you are supposed to iterate on a program. So maybe you first give it a menu, do this, select this, whatever you want to do there. And then after that, you need to ask the person, do you still want to continue? Like here, I can say maybe print F here. So print F, and then I'll ask the user, like, do you want to continue? Do you want to continue? Or maybe instead of say, do you want to continue? Maybe I can just say to continue. Please enter 6. No, not 6. Please enter. Maybe I'll say please enter 1. And maybe I'll put a slash n, and I'll say to exit. Maybe enter 6 here. I'll say enter 6, something like this, right? And then I'll put another slash n. And then what I'll do is here I need a scanf, right, to take the user input. This is just a simple example. So for scanf, I need to put %d was an integer. And here I'm supposed to put an address operator. I'm supposed to put an address operator. When you're using a scanf, you need to put the address operator. Let me just store the result in maybe in B here, and by default, let me put a 0 in B. Okay, so what I want to do is I'm going to say while I is equal to is less than or equal to 5. Okay, is this the condition that I still want to know? So I'm going to say while B maybe is less than or equal to 5 here. Keep on doing this, right? Something like that. So we know that by default B is equal to 0, right? So here, the value that you're going to put here is going to determine if you are going to keep on executing this. So if you put 1, it's obvious because B here is less than or equal to 5 and 1 is less than or equal to 5. So it will keep on executing. But if you put 6 there, it is going to actually go out of this loop. Why? Because now 6 is not less than or equal to 5, something like that. So if you have such scenarios, you can use a do while loop. You can do something and then you can, so it is going to print 1 day, then it will say to continue, please enter 1, and to exit, enter 6. So for me, I want to continue, maybe I'll just put a 1 there, so it will print 2, and then it ask me to continue, please enter 1, then to exit, enter 6. Let me put a 6 there. They need to say out of a while loop, or so it's a do while loop, and then boom, your value exit, and so it will exit this, and then it will print this statement, then you are good to go. So that's how you use a do while loop, or that's how it works. So it's just a matter of doing this whole task, and then it will compare the condition, do this whole task, then it will compare this, it to check on this condition. So if this one's true, it will keep on executing whatever inside this do while loop. So normally these things, you are learning them in pieces, right? And then when you're given a problem, now you need to evaluate, am I going to use a for loop? Am I going to use a do while loop? Am I going to use a while loop? What am I supposed to put together? Maybe you are supposed to use a do while loop at the same time using a for loop again, where you are supposed to nest a for loop inside there. So you just need to familiarize yourself with these things so that whenever you are presented with a problem, you pick the best solution or the optimum solution. So that's all on on a do while loop. If there are no questions, allow me to look at the for loop, to look at a for loop. If there are no questions and contributions, allow me to look at a for loop. This one, normally it's quite a little bit complex, but very, very easy. So this one is it's a for loop, and this one normally you need to use it whenever you know that you want your code to execute for exact number of iterations, whatever that you know, then you can go for this what we call a for loop. So this one is a loop that repeats a block of code a known number of times. Like we actually know that this is supposed to iterate maybe for 10 times, maybe for 20 times. That's when you are supposed to pick the for loop. So the syntax is very, very simple. I just need to get used to it. It's very, very simple. So I just need a highlighter, not a pointer. Okay. So you have this for keyword, and then you have got this initialization part, and then you have the condition, and then you have the increment. So these things, guys, are statements. That's why we've got these semicolon at the end. These ones are there for termination. So you put the first statement, you terminate, the second statement, you terminate, and this one again, you terminate. And then also you need to understand, then you have got this block of code. We've got this block of code which is going to be executed whenever this condition is true. Then you just need to understand the order of these things when they are being executed. You need to know the order, right? Is this one going to be first executed, or is this one going to be first executed? And maybe that's how you can master this for loop. So for example, if got this for loop for int I is equal to 0, I is less than or equal to 5, and then I plus plus. This one is just going to give us the same output like what we are doing with a while loop and a do while loop, but now we are using a for loop. So we need to understand like how does it execute, or how can we get the output from 1 to 5. Okay, so what I'm going to do here, allow me to take out all these things. All right, then here I need to put out of for loop. I need this one so that we could see when it actually exited the for loop. So we are going to have a for loop. So from the syntax, guys, from the syntax, we're going to have these things. I normalize putting these things first because these are the simple things to forget. All right, so here we've got the first initialization part. On this initialization part, remember when you're doing iterations, you normally have a variable that you could use to iterate from 0 to whatever, from 1 to a value that you want to reach. So normally you need to initialize that a variable with the initial value. For example, here when you're doing the while loops, we're using int I is equal to 0. Like firstly, set I to 1. So I initialized with 1. So we're initializing I to 1. So now we no longer want to initialize I here, but now we want to initialize. Let me just comment out these things, unless if we need them. So let me just comment them out. So first things first, you need to initialize your variable. So that's the first thing. So we are going to initialize I to 1, and then you are going to put the condition here where I is less than or equal to 5, right? And then I'm going to put I plus plus. Guys, to those who do not know I plus plus, what does I plus plus mean? You've said that this is as good as I is equals to I plus 1. So you are just incrementing the value of I by 1, something like that. That's the I plus plus. So if I is equal to 0, then if you say I plus plus, the next thing the I is going to have a 1 because it's 0 plus 1, something like that. Then you store the value in I. So that's the I plus plus. So you can even write that I is equals to I plus 1 here. It's doable. Why? Because this one is a statement, this one is also a statement, something like that. So you can write this one here, but I normally like to write I plus plus. Why? Because whenever you are reading, you see that thing. So here we need to put what we are supposed to do or what we want to do. So to keep it simple, we just want to print the values of a of I. So sorry, so here I just need to put percentage d, and then let me put a slash n. I just want to see it like 1 2 3 4 5 sheets, you can it. So after that, I'm going to have an I here, something like this. Okay, so if I run this, what could be the output? Obviously, the output is going to be 1 2 3 4 5, and then I'll get an out of loop. Why? Out of for loop. Why? Because this condition is going to allow us to only end at I is equal to 5, because the condition is saying I is less than or equal to 5. So maybe I'm going to execute and we see the output, and then we try to generate that output using this for loop. So for now, let me just limit it to maybe just 3 for demo, so that it will be faster for us when I'm doing the demonstration. So I'm going to get 1 2 3 and then out of for loop. So how is it doing this? How is this actually happening? Okay, so what is happening is this. Let's, oh, this one is not on a, I cannot have a highlighter here, but okay, allow me to use the slide. Allow me to use the slide. So how is this actually happening? What is happening is just as simple as this, guys. The first thing is when you're executing a for loop, it is going to first initialize the value of I. So this one is the first thing to be executed at a for loop, the initialization part. So it is going to set I. The value of I is going to be set to what? It's going to be set to 1, something like that. So the value of I is going to be set to 1. And what happens next is it will execute this condition, right? So the second thing to be executed at first, so is this I is less than or equal to 5. So it will check, is it 1 less than or equal to 5? Yes. So what does it do? It gets inside this loop and execute the code, right? So it will print the value of what? So it will print the value of I, and it is 1. So it is just going to write 1 to the screen. And then the next thing is, after printing this, it will go on to increment the value of I. So we have started here, checking the condition, do this, increment the value of I. So now the value of I will become 2, because it was already what? It was already a 1, so it will become a 2 there. Don't worry, I'm just using the touchpad. So it won't be easy for me to write. So we are going to get an I now is equal to 2. So what does it do? The next step now from here, it's not about going to in the initialization part here. It will now move from here to here. So first you are here, check the condition, run this, increment, then check the condition. You are no longer go here. So it will check the condition. So is it 2 less than or equal to 5? Yes, then it after checking the condition, it will get inside the block, it executes this, and then it will print out a 2. So because we do not have a slash n, so it is just going to give this, it is just going to leave this space and write a 2 here. A 2 here, something like this. So the next thing after printing this, it's not going here, it's just going to increment, and then we get our IS 3 here, and then it will go here, check the condition. Is it 3 less than 5? Yes, so print 3. So it will leave some space, write a 3 there. Then after that, it will increment. So it will be now a cycle here just like this, till this condition becomes false. So first initialize, check the condition, execute, increment, check the condition, execute, increment, check the condition, execute, increment, just like that. So that's how this for loop actually is being executed. So these are the basic things that you just need to understand. So that's how are we getting a 1, 2, 3. So for them, they were just putting a space here rather than putting, so it is just going to be 1, 2, 3. Then it will say out of for loop. Why? Because after the condition checks here, is it 3 less than or equal to 3? Yes, they need to print 3 here, and they need to increment. So 4, is it less than or equal to 3? No. So it will just jump this whole code here, and then it will do whatever comes next after the for loop, and which is this statement, which is out of for loop. So that's how a for loop actually works. I don't know if I've got questions or whatever on this one. Maybe there's what we call a nested a loop or a nested for loop. There was something in the chat. What was it? Here, my network is tripping. Okay, I'm recording. I hope you get to listen to what we are recording. Okay, so maybe there's what you call a nested loop. Normally, especially when you're going to do multi-dimensional arrays, you need to actually know the nested for loops. So you can nest if in a while loop, you can have the outer while loop and the inner while loop, something like that. So you can have these things nested inside, or you can have a nested if a statement, whatever. So when I'm saying nested, it's like you are going to have another for loop. For example, here I can have the outer for loop just to print I, and then I'm going to have another inner for loop to print J, something like that. Okay, so how does this work? So can we make sure that we are always on mute? Yes, thank you for that. Let's make sure that we're always on mute. It will help us to actually do the tutorial without such disturbances. So I was talking about nested for loop. When you say nested for loop, it's just to have another for loop inside another for loop. So I have this outer for loop and this inner for loop. So this outer for loop is just going to print the value of I, right? And then I'm going. So you can also do this when you're doing the patterns. You're being asked to do something like that. If you want to do some patterns, you can also use this such kind of having this. So I can have maybe here. Let me just have instead for I can have int j, maybe starting from 0, and then let me just start from 1 here, something like this, and then I can have j is less than or equal to 5. Right. Let me have um a 3, or let me just leave it as a 3 there, and then I can have j plus plus. Okay, so let me have a print f, something like this. Don't worry about it, the output that we're going to get. So here I'm just going to print j, not j, but let me just print percentage d, and then here I'm going to put some space, and then I'll put j here, right? So it's as good as this inner for loop. So this is the inner for loop, this is the outer for loop. This one is the outer for loop, which have got everything in here. So what happens is, so for this one to be a little bit, what can I do? Okay, let me put a slash n here. Print f, let me put a slash n here. Maybe sorry about these things, they're getting a little bit out of handy. Let me try to execute and explain. So what is going to happen here is that the outer for loop is going to print the value of I, and then the next thing it is going to print the value of j. The values of j, this inner for loop, when this one execute once, this one execute 5, this code here of will execute 5 times. So maybe you're going to have maybe a 1, then you have 1, 2, 3, 5, then maybe you have a 2, 1, 2, 3, 4, something like that. I think that's going to be the output. Yes, you're going to have 1, then you have 1, 2, 3, 4, 5, then you're going to have a 2, then 1, 2, 3, 4, 5, then you're going to have a 3, then 1, 2, 3, 4, 5, something like that. So how is this actually happening? This one. So what is happening here is first thing is we have said that we execute for the outer for loop is obvious, it's the one which is going to be first executed. So it is going to execute this one. So it will initialize I with a 1, and then after that it will check, is it 1 less than or equal to 3? Yes. So what does it do? It will print the value of I, which is what? Which is a 1. So it will just print this one. Oh, let me, for those with the questions, just you can hold your questions as I'm trying to explain, and then I'll come back to you so that you ask your questions. I just want to execute this so that we could do actually see what is happening here. So, so after printing this first one, what happens is this. The next block or the next statement to be executed in here is a for loop. So it will bump into another for loop. So what does it do? It just follows the same way that a for loop is actually supposed to be executed. And what's that? Is to check is is to initialize j with a 1, and then check is it 1 less than or equal to 5? Yes, and then it will print this 1, and then it will increment the value of j, and then it will check is it 2 less than 5 or equal to 5? Yes, then it will print this 2, and then it will do the same for it will increment it, then it will be a 3, then it will increment, then that's when you get this 4, and then it will increment, that's when you get this 5, and then it will increment, then is it 6 less than or equal to 5? No. So what does it do? It goes out of this inner for loop, and then it will go to this print FR pineapple, because that's the next line to be executed after you've exited this inner for loop. And what does this printf do? Is just jumping a line. So it will jump a line, and then you come here waiting to do the next task. So what's the next task? The next task is to increment this I by 1. Remember, we've checked this when we got 1 is less than or equal to 3, and we've printed 1, and we've done whatever we are supposed to do in here. So the next thing is to increment this by, I think I need to admit those who want to join and let them, and let's make sure that we are always on mute. So the next thing is to, let's make sure that we are always on mute. Let's make sure that we're on mute. Let's mute ourselves. Yeah, the problem is those who are just joining, their mics are on. So let's make sure that we are on mute. Let's make sure that you're on mute. So if you look at it, so now after executing whatever inside, we need to increment I by 1. So we're going to have a 2 less than or equal to 3. Yes, so it will print 2. That's why we have got, so that's why you've got this 2 here next. And then it will do the inner for loop again. So this one is going to execute 3 times. But whenever it executes 3 times, it is going to print, it is going to execute all its 5 iterations, while this one just executing once. So when you execute the outer one, just 1 iteration, this one execute for 5 iterations, then this one, second iteration, this one go for 5 iterations, something like that. So instead of maybe printing a J here, maybe I can opt to print maybe just some, maybe some stars. Let me see what could I get here. Maybe if I print some stars, okay, those are just 4 stars there. What about if I put maybe just a space here, nothing else? I do not want to print I. What could be the output? So I was just getting in a 1, 2, 3, and then this one's okay. I didn't run this one, so I'm just going to get maybe this stars, something like that. So if you're being asked to do a pattern, maybe if you're supposed to print some patterns, okay, I need to actually close this. Okay, maybe if you're actually being asked to do a pattern, for whatever reason, you now need to model this inner loop so that maybe it will be no longer just printing 1 to 5, 1 to 5. Maybe as you are going higher there, maybe if I just twist this one to become the value of I had I've changed a lot of things there by just doing so. You see now I'm just starting by printing 2, 4, 5. stars, and then I'm printing the next thing, I'm printing 4 stars, next thing I'm printing 3 stars, something like that. So if you look at it, what if I allowed this one to go to 5? I'm just playing around with these numbers. I'm sure I'm going to get something, this pattern. You are seeing this pattern: 1, 2, 3, 4, 5, 1, 2, 3, 4, or maybe something like that. So these stars are actually ping on are actually reduced on every iteration, something like that. Until, so that's how you produce these patterns, something like this. So the magic is around the use of this inner for loop. So for those who wanted to ask some questions, now you can ask. It's a Crespo Chitiga. You want to ask something, or you want to contribute? Do you want to say some Chitiga?
Yes, I wanted to ask.
Yes.
I tried the first code that you coded for the for loop,
Mhm.
and my code is just keep on running, like it's not stopping when I
You've
compile it.
created
I don't know what's going on.
you've created an endless an endless loop.
Who- Where did I do the mistake?
Obviously, you have messed around with these numbers. The initial value, maybe there's a feedback from someone's mic.
Okay, let me cut mine.
It's not yours. I don't think it's yours. This embarash. Okay. So
Okay,
so okay, so maybe the issue is around here. That's where you can create an endless loop. It's very, very possible. Just
okay,
imagine, just imagine, I was starting from I is equal to 1. So I was starting from 1 until I is less than or equal to 5. And the operation here is I plus plus. What if I put a decrement operator? What does happens? I'm decrementing I by 1. So it will be starting from 1, going to 0, -1, -2. So this will become an endless loop in the sense that obvious I'm going to have negative values going down there,
down.
and it's not going to be something which is going to be, oh, okay, so this one is less than, oh, so this one is less than or equal to 5. Yes, exactly. So it will become an endless loop. So every number that I'm going to get is going to be less than or equal to 5. So that's what you need to look for and avoid. So I'm sure if you look at these, just these 3 statements here, it will tell you that you've created an endless loop, something like that. And someone was asking in the Anita, you want to say something? You want to ask something?
Yes, sir.
Yeah.
Okay, from the example that you're doing,
Yeah.
I'm trying to understand the difference between like a while loop and a for loop, in the sense that you said the condition is I is less or equal to 5. So
Yes.
while loop, it means that it's going to end at 5, isn't it?
Yes.
So what's the difference between that and the for loop? Because the for loop is just it structures the code in a way that there's an initialization, then there's a condition, then there's, but then isn't it the same thing as the while loop?
It,
It's
it, it, it,
at
it, it- okay.
5. The condition is less or equal to 5 in both cases.
Okay. So here it's now depends on what you want to achieve. But these things, trust me, they are actually different. These things, they're actually different in the sense that for a while loop, normally you need to put the code inside, which actually tells you how many times are you going to execute this code, right? So sometimes you do not know how many times do you really want to execute this code. So you need just to module it with a while loop. But whenever you know that I need to execute this for 10 times, you go for a for loop. Why? Because on just that one statement, you can do that, right? But if you do not know, you cannot do it here. Why? Because here you are not writing code. You are just declare. It's like you are declaring the condition, and what you are supposed to do on this side. But with a while loop, it gives you a room to write all the code that you think is the one which is going to end your loop, something like that.
Mhm.
So whenever you have a lot of variables which determines the end of your condition, whatever, now you have a chance to write them in here, inside here, and then it will affect the condition maybe later on after, something like that. So something like that. So you are not seeing the difference just because here we are just doing basic examples on how to use it, right? But in real world, there are such scenarios where you need to iterate the code, but actually do not know the exact number of iterations that you need to do. But you know that maybe after doing this series of steps, maybe I know that I'm supposed, like for example, like what I was saying, if you want someone to put a password, right? Actually, you do not need them to put it inside a for loop, and you say maybe it is going to iterate 3 times. Why? Because what if the person goes it correctly at the first step, something like that. So it's something like now you need to put the code in a way that uh in a way that
While
Ella,
loop like the no, I'm just trying to get clarification. Like a while loop is when you're not exactly like certain of when the outcome is coming.
yes,
Loop is like when you know you need to do this a number of times, and
yes.
that okay.
That's the main difference with a while loop and a for loop. Yes. So I don't know if I've got any question or any contribution. There was someone who was asking about this asterisk in the comment section. I saw someone who was asked how do we do asterisk? Guys, this is the basic thing. Um, Actually, this is typing. This is typing. It's no longer C programming. So thank you for asking. So on my keyboard, I've got a key 8 at the top there. I've got a key 8 and a star or that asterisk at the top. So you just need to use the shift key. So you click on shift and then you press banner 8 up. Then it will print whatever on top of that. Something like that. But if you've got a function local at your keyboard, a function kagara kari locked up, obvious, maybe it will work vice versa, something like that. But that's what you're supposed to do. For me to get this star, I just need to click at shift and then I'll press it banner 8 up. So you just need to look at the keyboard. Maybe it's not going to, but mostly the QWERTY keyboards are just the same. I hope you are answered, and I hope that's what you were asking for. Say it is still not ending. Maybe what you can do is you can just copy your code and post it there. Maybe I could figure out what could be the errors. Obvious, we do generate errors as we code. You see me, I'm going to generate those errors. It's very, very simple to generate these errors. That's why we are programmers, right? And that's why we debug. And that's why we love to debug code, right? Got such error then to mandate. So you can actually copy your code and paste it here so that we could do. Even mine, I'm using code blocks too. Guys, if you have an issue with the code that you are trying that side, you can try to copy the whole code and post it there as a message there. I'm sure you can do that. And then I will just have a look at it, and maybe we can go through as a class and see maybe where you have made errors. It's very, very easy to make those common errors so that I can easily pick those things. Okay, otherwise, that's how you do a for loop. I hope my time is still okay. Okay, my time is still okay. So, guys, that's how you do a for loop. And that's how you can also do some patterns there. Those who have got an interest on doing this, these are very, very basic things that you can do of creating these patterns. But don't worry about this. No one's going to ask you about them, but it's a good thing to practice. Why? Because you get to understand how do this for loops works. It's very, very easier to get lost with these things. So I was hoping that someone was going to copy. Okay, someone have actually pasted the code. Um, okay, this is where the problem is. I didn't. The problem is here. You are putting a 1 here instead of I. So it is going to, obvious, 1 is always less than or equal to 5. So 1 is always going to be less than or equal to 5. So you are going to keep on looping whichever the value of I that you're going to. So maybe your I is now at 1000, but you are still your condition is still saying, is it 1 less than or equal to 5? So that's the most easiest way to get lost with these things. This one, let me just put it here. Maybe I can just copy the for loop here. Very, 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 very easy way to make these mistakes. So your code here, if you look at it, you are saying int I is equal to 1, and then 1 is less than or equal to 5, and I plus plus. So what is happening here is that you are always, your condition is always saying 1 is less than or equal to 5. So whenever you have your I maybe it's 20, but when you come here to condition, you are just say, hey, check, is it 1 less than or equal to 5? Something like that. So I hope you have managed to solve this, and so that's how we are generating the. So maybe what you are supposed to do here is you are supposed to replace this with an I. That's a simple and easy fix. If I run this, I'm going to get 1, 2, 3, 4, 5. Okay, so normally when you are doing programming, you get locked in. So zvinogona kuita zvodzoka zvokunetsa zvonotadza kutoona kuti error yacho iri pa, but if you keep on chasing the errors, mostly the very, very important thing is to know where to look for the error. That's the very, very important thing, and it will save your time. Anita, you want to say something again?
Yeah, I wanted to ask something from that guy who made a mistake in his code.
Okay.
Isn't it supposed to put an I and then they put a 1? Let's say you said in the exam we're going to be writing on paper,
Yes.
right?
Mhm.
So if I make such a mistake, does it mean like the whole code is wrong?
It's obvious it's wrong. You've created an endless loop instead of creating that loop that which is going to print 1 to 5. Okay, your code is not going to print 1 to 5. It is going to keep on printing the values of I going, but it's not going to end. So if you were asked to print maybe 1 to 5 using a for loop, and yours is not printing 1 to 5, and you are at the mark, what can you do, Anita?
I get it. I get it.
Yeah, I think zvinogona kutibatsira tikamboita tichichinjana maposition handiti. So maybe what now what we look at is when you are marking, it's the first thing is to just check, is the code running. That's that's the first thing, is to check, is the code running. Then we know that the student is doing actually knows what he or what she is doing, something like that. That's how you see a first class student from, that's how you distinguish the first class student from all other students. Not according to run a bobo. Okay, so is he doing the right thing? That's the second thing. Yes, he's doing the right thing. Okay, so for that person, it's actually easier to score more marks or to score all the marks, right? But for you now, you have done this. Now we are now looking at your code, because obvious the mark is not just only at having something running and giving the correct output. It might be running but missing the output, but you have actually put maybe the syntax for loop is correct there, and you're actually printing the value of I, and that's what we are supposed to do. And actually maybe that's how we mark. We are not just going to look at, is it going to give me the correct output, then it's 5 marks, and then if it is not going to give me the correct output, then it says 0. No, it's not like that. But normally that's how we look at it. So now maybe I don't think I've got questions. So now let's look at the next thing. Maybe the next thing to cover, let's look at arrays, and then we look at pointers. Yeah. Let's look at arrays, then we look at pointers, we look at structures, or let's just look at pointers. Then we look at arrays, and then we look at the structures. Why? Because when you're doing arrays, when you're doing structures, sometimes you need to use arrays. Like the question which was on your assignment, I think it was, you were supposed to use the structures with arrays to do some task there. Excuse me. I'm sure you know the best than me, because I didn't write that assignment. It's you who wrote that assignment. So I think you know better than me on those things. Maybe I'll try it, but you know better than me because I didn't even try to run that code. So I know if I go through the question, I know what we're supposed to use, but I think somewhere you're supposed to use arrays and the structures. So now let's look at what we call pointers in C. So this animal that we call pointers in C. So what are these things that we call pointers in C? So a pointer is a variable that stores the memory address of another variable. Take this, guys. Pointers are just variables. That's the first thing to note. They're just variables. So if you know the definition of a variable, you know what a pointer is, but only that this one, on being a variable, it stores something special. Why? That's why it needs another name. Instead of just being a variable, it needs another name which is more than a variable. Why? Because it stores something special. And what's that? It's a memory address. So this one, it stores a memory address of another variable. So take a pointer as a variable, but now it stores the memory address of another variable, something like that. So I think someone needs to join. Okay, let me admit. So sometimes let's make sure that we are always on mute. So think of it like a memory GPS. So it points to a location where data is stored, something like that. So how does it work? Normally you have a variable, then memory location, and the pointer is points to this memory location, right? So you have a variable, in that variable you've got a memory location, and take a pointer which is pointing to that memory location, something like that. So maybe why do we use pointers, or why do we need pointers? Yet we already have variables. So why do we need to store the address of another variable? So normally these ones, they are very helpful to access and modify variables directly through memory rather than through the variable itself, something like that. Also, efficient handling of arrays, functions, and dynamic memory location. Also, it is essential for advanced topics like the data structures, where when you're going to do the linked list, trees, next semester you're going to do data structures. So you need these pointers, you need the structures, you need arrays. Those are going to be key data structures, or they are going to be key things that you need on the data structure there. So the syntax is very simple. To declare an array, you write type. It's as good as to declare. So you write type, then you put that asterisk or that star, and then you say name, something like that. For example, you say int, and then you put a star there or asterisk, and then you put the pointer name, right? So the name, we have done the rules of naming identifiers, or the rules of naming variables, what. So you just need to put a valid name there. So here now, this pointer is a pointer to an integer variable, something like that. Now it doesn't have any value, but it's a pointer pointing to an integer variable, something like that. So we can have this example, which shows you that we have a variable that we've declared, which is called num, and we've stored 10 there. And now we can have this pointer pointing to the address of num. Remember, this one we called it this ampersand operator. We called it an address operator, right? So this one take the address of num, and then it will store it in the pointer, something like that. So what it does is that this one now is the PTR, the pointer now stores the address of num, not the value 10. No, it stores the address of this variable num. So somehow this pointer can actually get you a 10 there, or can get you the address of something like that through the use of dereferencing operator, or what we can talk about this. So let's try to do maybe some simple example here. We can have like this one. We've got int num. Let's store a 10 there. And then let's have maybe like int. So if you want a pointer, let's make sure that we're on mute. So if you want a pointer that points to an integer variable, it needs to be int, the type of that pointer, right? So if you want a pointer which will be pointing to a character variable, so the pointer itself needs to be of type char, something like that. So here I can have, then you need to put this asterisk, and then I say ptr, right? So if we, so I can declare it just like this, or I can actually put the value there. And that value is supposed to be the address. And how do I get the address? I use this address operator and I'll put the variable there. So this means that now ptr actually have the address of this variable num. So if you see here, if you want to print the value, which is 10, you do that. And if you want to print the address now, I'm sure if you want to print the address now, you are not supposed to dereference it like this, but let me try it. Do I still remember it? Okay, let me just print ptr, and then let me put, if I say %d here, and if I put the dereference operator like this, I'm sure it is going to give me that 10. Let me try it. I'm going to get 10. Why? Because if you put this dereference operator, it means you want to access the value which is at the memory address, which is in PTR, something like that. That's how you do it. So if I remove this, obviously it's going to give me the, but yes, it's going to give me the address, which is PTR. But now I was worried with the use of %d. Am I supposed to use this one, the %d, or is this supposed to be a string? Or but what I know, this one is just a number there. It's just a number. It's the address, but because I'm printing it as an integer, yes, it should work. It should work that way. It should work that way. You can go and explore this and see if I'm supposed to put %d here or I'm supposed to put anything there. You can go and look at this. But whenever you do not put this star here, it is going to give you the actual address of this variable now. But if you put a dereference operator here, it will give you the value at the address within this pointer, something like that. So that's how you get that's how you modify the value at a certain address. So if you want to modify the value at a certain address, you need to use the dereference operator. Let's make sure that we are always on mute. That's that's how you can do. So if you want to change the value in num to 20, you just need to use this dereference operator. We call it dereference operator. That's the name. So if you put a star here, then PTR, and then you put a 20 here, you are initializing not this PTR or this pointer, but you are initializing the value at the memory address, which is already in PTR, something like that. So if you want to change the value of PTR, you need to remove this asterisk. Then now you are dealing with the PTR itself, something like that. So that's how you work with these pointers. That's how you work with these pointers, something like that. So I don't know if I've got questions. For many codes, you can go and explore on pointers. But what I want you to know is when you're dealing with the pointers, normally you're dealing with the memory itself. Why? Because you have the address of a certain variable and you can actually change the address of that. You can change anything in that. For example, here, what if I say star PTR, let me try this, and then I'll put maybe 40 there, And then instead of printing this, let me print the value of num here. Maybe let's see the magic and how powerful is this. And then I'll print num here, something like this. So I want to say num is, so here we have declared num as 10. We have declared and initialized num as 10. Let's see the value of num. Is it going to be 10? No. Num is actually 40. So why are we getting a 40 num? But actually when you declared it, we've put a 10 there. It's, and here you didn't see me changing the value of num. But what I did is I changed that value through this pointer. This pointer, I've got the address of num, right? So I'm writing straight, or I'm writing direct to this variable by just going to write to its address. It's like, okay, I know the address of num, so I do not need I don't need the num variable anymore, or the name num anymore. I can do it directly to the memory address. I can do it directly to the memory. So that's how you can use pointers. This one's very, very important when you're doing the data structures part. There you can, that's when you need these pointers more. Why? Because we are doing linked list, now they need to be linked, so you need to keep on sharing the memory address of a certain node to another, whatever, something like that. So we leave it to data structures. But basically, that's what we want you to know on the pointers, that a pointer is a variable, but it's a special variable. Why? Because it stores the address of another variable, something like that. Stores the address of another variable. Also, this pointer now allows you to dynamically change the data through through the memory address, something like that. Also, it comes in handy when it comes to data structures. You see, when you're doing data structures, you are going to do C++, and you'll be using the pointers, and the syntax will be the same for C++. So basically, that's all on pointers. Maybe now we need to look at arrays before looking at structures. And here, guys, this is very, very important topic on arrays. Maybe it was supposed to be the first thing that we're supposed to look at today before looking at loops, but somehow we are still on track. There's no problem. But when it comes to arrays in C, we are supposed to do arrays from those single dimension to maybe 2-dimension arrays. So what I'm going to do is we're just going to do 1-dimension array. Then I'll allow you to go and explore the multi-dimension array. Why is it so? It's because maybe when you're doing data structures, you might be required to actually do multi-dimensional arrays, something like that. So please go and look at them. The multi-dimensional arrays, they're very, very simple. I'll give you a hint on it, and then you go and look at it. But for today, we're just going to look at a single dimension array. So before talking about single dimension array, multi-dimensional array, we just need to understand what is an array. First, that's what you need to understand. So an array is a collection of variables of the same type stored in one place. Just imagine if you want to store a list of data, right? This data is of same type, right? So maybe you want to store maybe 100 numbers there, or maybe a max of 100 students. So you need to declare a variable for each student, something like that. But with arrays now, you can now take a collection of those variables and put it under one variable. So an array is a collection of variables of the same type stored in one place. So take a note of this thing. When you go for data structures, whatever, you'll be asked about, maybe you'll be asked about what could be the advantages and what could be the disadvantages of arrays. You are seeing that this one is the best idea. Why? Because it stores a collection of variables under one variable name. But look at it. these are variables of the same type. So you are limited to that of the same type, something like that. So if you are going to compare it with our linked list, whatever, those other data structures that can accommodate different types of data, then it is going to have such disadvantage, something like that. So it's like a row of numbered boxes in a memory, each holding a value. So when you're talking of an array, think of it as these boxes in a memory that we're going to have. So this one is supposed to be a one variable, another variable holding a value, something like that. So it is going to have these boxes of values as well, what you call an index or indices. So in an index, it will be like this one will tell you that the first box will have an index of 0. So it will be numbered 0, 1, 2, 3, 4, 5. So the box will be numbered, and those numbering, we call them indexes. It allows us to actually access any box that we want to access, right? Something like that. So arrays let you store multiple values under a single name. For example, int nums, then you put 5 in those whatever square brackets, something like that. It's like we are declaring an array that can hold 5 integers instead of creating 5 separate variables, something like that. So you have created something like this something like this in memory that can hold 5 values, 1, 2, 3, 4, 5. But the index now will be running from 0 to 4. Why? Because the first box will be numbered with a 0. So it will be 0, 1, 2, 3, 4 to make it 5, something like that. So that's how we actually declare in an integer array, something like that. So in C programming, we do not have strings. Actually, strings you can actually import as a class, but normally we do not have the string basically in a C program. So you can actually create someone's name through the use of arrays, but now it will be an array of characters instead of array of numbers, something like that. So why using an array? Arrays make it easy to manage a list of items like scores, temperatures, etc., something like that, without many variable names, and you can loop over them to process each element. So yes, this is the beauty of it. You can do a for loop and loop over the array, maybe finding an average, something like that, average temperature, or maybe finding the maximum temperature within the array, something like that. So now it will become very, very easy. Also, you can store and work with many values of the same type at once. For example, int data, then you put 100 there and it can hold 100 values within just one name, something like that. So how do you declare an array? This is the basic syntax. Int arr, this is the name, this is the type, and then this is the size. That's why for type, name, and then size, and these square brackets, and then you terminate. So sometimes you can declare and initialize, something like that. So declares an array named arr of 5 integers. I need to accept someone here. So normally that's how, I hope our time is still okay, 23 past 2, okay. So normally, basically, that's so at 3. I think we need to actually switch to mathematical foundation so that we are going to have those who will be presenting, something like that. So so the size must be a constant or a literal. So this size must be a constant there. So it determines how many elements the array holds. And once declared, the elements are indexed from 0 up to size -1. This is very, very important. They are going to be indexed. So the first box there, it will be a 0 up to size -1. So if we declare with the size 5, obviously the index is going to run from 0 up to 5 -1, which is going to be a 4, something like that. So let's get these. These are the basics, right? So we've declared. So how can we initialize? Normally, that's how we initialize an array. You can declare and initialize, or you can declare and initialize later. Very, very, you need to understand it. All right. So you can initialize an array at declaration by listing values in these curly braces, something like this. So the values will be comma separated, or you can do it by putting the index, like if you declare an array of size 5, and then you can just say array at index 0, something like that. But if you just do this, trust me, the first value or the first value at index 0, the first box is just going to have a 1, and then the next one is just going to have a 2, the next one is just going to have a 3, until the last one at index 4, which is going to get a 5, something like that. So if you omit the size, if it happens that you omit the size here, the compiler infers it from the values. So if you are going to have 3 values here and it happens that you didn't put the size here, so the array is going to create an array of size 3. Why? Because here you have given it only 3 elements, something like that. So that's how you do it. So how to access, if you now want to access the value at a specific whatever within the array, now you need to use the specific index. Like here, you just need to write the array name, and then you put the index, and then it will give you the value at that box. So normally you can reassign my values as well by just picking the specific index and then you put the value. So something like that. So normally that's how you do it. So maybe basically we can go before doing the loops, whatever. Maybe we can just go try to demonstrate the basics, and then we look at these for loops. When you be asked me to find the average, how can you do it? Or maybe you are supposed something, or maybe you are supposed to sum all the elements within an array. How do you do it? Something like that. It's very, very important. It's very, very important. Or maybe we can do it later, but let's just do a quick demo on these arrays. All right. So here, let me just have an array of integers, right? Let me just name it ARR. And then here, let me just put it maybe a size of 4. And then here, let me just put some curly brackets. And let me just put 1, 2, 3, 4, right? Something like that. Then let me terminate. So I've declared an array of size 4, and it is going to hold the values 1, 2, 3, 4. So whenever I want to print this, I can do it by say printf, right? And then in here, I can have maybe let me print array. Maybe I'm just trying to make it maybe look this way. Okay, so here I'm going to put this, and I'll explain what is happening here. So guys, we've said that whenever you declare an array like this, it is going to have an index and the actual blocks of values there, right? So like this one, we have got this array of size 4. So you are going to have an index going from 0, 1, 2, 3, right? And the values are going to be stored at index 0, or at box number 0, the first one, we are going to have a 1. At box number 1, we're going to have a 2, something like that. So if I put array at index 0 and I pass the index here, it's no longer the size here. Now it's an index, or it's only the size when you are declaring here, something like that. So if I run this one, I'm going to get a 1. Oh, I left the percentage D here. I was supposed to put the percentage D. No one actually told me that I was supposed to put a percentage D. That's why I just got nothing there. So that's why I'm getting in array at index 0, the value is what is 1, something like that. So that's how you get the values if you want to print those values, right? So imagine if you want to print what about if you want to print the whole array? You need to do it for index 1. Now you put index 1 here. You do it for index 2, something like that. Let me put some spaces after printing this, something like that. You need to do it for this one. Is a bad idea of doing things, right? You have done it for index 0. You do it for index 1, something like that. It's a bad idea of doing these things. Let me just allow this one to join. So that one is a bad idea of doing it. That's not the way of doing it, but normally it can work. Let's make sure that we're always on mute. Anele, let me mute you. Okay. So if you want to change the value, maybe you want to change the value at index 0, which is this one. I want to change it to become 5. What can I do? I can just do this array at index 0. I want to change it to maybe 20, something like this. So it means that whenever I try to access index 0, I've changed it to a 20. So I will get this value 20 here, and this 2 will remain here at index 1, something. So that's how you modify the values. That's how you also get the values from an array. So what about if I want to print all the values in a simpler manner? That's when those for loops, those while loops come in handy here, right? So you can simply do it by just having a symbol. Allow me to cut this. I'm good at cutting and pasting these things. I know for this one, I'm sure I can do. But guys, one word on this: do not copy things that you do not understand, right? Yes, I know I'm good at copy and paste, but I always do so with things that I understand. Otherwise, I need to learn something and then I will try to play around with the code, right? So here I can say form int I is equal to 0. It's always good to start from 0 if you want to loop through the whole array. Why? Because the index runs from 0, right, until size -1. So the condition now needs to loop from 0 until the size -1, something like that. And the array size here is 4, right? So it should be run from I is equal to 0 until I is less than or equal to 3. And then I'll put I plus plus, right? So here I'm going to print, instead of putting a 0 there, now I need to put an I, right? So let me just remove this so that I'll write maybe 1, 2, 3, 4, something like that. So let me run this and see the output. I'm going to get 1, 2, 3, 4, something like that. So how does this happen? It happens just because I've got an I here. So so here we are initializing I with a 0. So is it 0 less than or equal to 3? Yes. So going to print the item at index I, and I is now at 0. So it is going to print the value at index 0, which is this one. And then we increment I to 1. So 1 is less than or equal to 3. Yes. So it is going to print something at index 1, which is this 2. Then we increment this one to become what? Sorry, it is going to print something at index 1, which is this 2, and then increment this one to 2. So is it 2 less than or equal to 3? Yes. So it is going to increment something at index 2, which is this 3. Because remember, it's 0, 1, 2, then 3, something like that. So you increment it to 3. So 3 less than or equal to 3. Yes. So it will print something at index 3, which is this 4. And then it increment this one to 5. Then sorry, to 4. Is it 4 less than or equal to 3? No. So it will go out of this loop and actually return something like that. So that's how you make use of this for loop to process the array. So what about if you want to sum everything within this array and print the total? So here I've got 1, 2, 3, 4. So if I sum this, I'm going to get a 3, 6, 10, right? So the total is 10. So let me try to sum this and get, so what you can do here, you can have maybe another variable here, int, maybe sum, put it to 0 like this. And then what can you do now to get the total sum? Maybe now you need to say sum will be equal to sum, maybe plus, let me allow someone to join. I've talked too much, but I hope I can finish this. Let me try to push so that we go over structures, and you'll be good to go. So maybe we'll be left with some questions to practice on, but if I fail to do so, I'll give it to you to do that task. It's very, very simple. I'm just feeling like I've talked too much, and I do not have some water to drink, something like that. But I think I have something. I have something. So for this, yeah, I have something. Okay, so so I was saying sum is equals to sum plus, okay, array at index I, then I'll terminate this. So what is going to happen is, at first, let's try it. At first is we are going to initialize I to 0. So is it 0 less than or equal to 3? Yes. So I'm going to take sum, which is 0, 0 plus the value at index 0, which is this one. So it will be 0 plus 1. We get a what? We get a 1, and then we store the answer in sum. So the next thing, we increment I by 1. So we're going to get I is 1. So 1 less than or equal to 3, yes. So we are going to take sum, and the sum now is what? Is 1. So we say 1 plus the value at index 1, which is this 2. So it will be 1 plus 2 to get a 3. So you keep on until you reach the end of this. And then we get the total sum, something like that. So now you print, that's how we do it here. If you put this printf inside, it is going to be printed 4 times. So you need to print the total sum just after this for loop. So here you can print that maybe the total sum is, I feel like there's someone waiting in the lob. Maybe I can just click it. Okay, let me just leave it. So here I need to put the percentage D for the total, and then I'll put some here, something like this. Let me try to compare and run this and see the output. Okay, the total sum is 10. Great. So you have seen that now it is actually easier to find the total sum of a given list of numbers. You can just have this simple for loop doing all the job for you. Is it not simple, guys, to do this? Is it not simple? I think something which is very, very simple, right? Okay, silence actually explains it why. This one's very, very simple. Say I'm not seeing slides. I think everyone is seeing my screen, right? That I've shared. Are you seeing my screen that I've shared? Maybe 1, 2, 3 to respond, and I will be
Yes.
sure. Okay, so Nyarai yes. Okay, so I think Nyarai, you cannot see it. So
Yes.
if it happens that you are not seeing my screen, you just need to maybe exit and rejoin. I'm sure it will be your network on your side. You just need to exit and rejoin. I'm sure everything's going to be sorted for you. It's
Okay.
unfortunate. It's unfortunate that I can do, because even if I try to reshare it, I'm sure you are going to face the same thing. Okay, so
Okay.
yes, so you really need to see what I'm demonstrating here, so that at least you get to understand. Otherwise, the explanation itself or the audio itself is not enough. All right, so guys, that's how you use a for loop to find that's how you use a for loop. So Yarai, now confirm if you are seeing my screen.
Yes, sir.
Okay, so yeah, I'm sure that's the easy fix. If it happens that you are no longer seeing my screen, that's what you can do. Okay, so this is how you can find the total sum. So what if you want to find the average now? If you want to find the average is just total sum divided by total number of elements, right? So it's now even simple. You just need to divide this number by 4, and then you get the average, something like that. So it's very, very simple to find the total sum, whatever that you need to do, something like that. So basically, I just wanted to demonstrate on this single dimensional array, right? Something like that. On how you can use them and how they are handled when it comes to programming. So guys, these are arrays. Go and try them, use them the way that you want. So this is how do you iterate. That's how you iterate on arrays, something like that. So that's what I've been demonstrating. So on arrays, this is over. You can go and look at more dimensional array just to have a look and feel on how do they operate. But this is the basic arrays and how you can use them. How can you alter the values? How can you get or how can you print the values from an array? So maybe if there are questions, you can ask. If there are contributions, you can contribute. Otherwise, our next destination will be on structures. Will be on structures. Yes, will be on structures, and I'll be happy that I've covered maybe everything that we need in C programming and everything that I wanted you to actually cover in a C programming. Um, if you take the first tutorial and this tutorial, then we are good to go. We are good to go. Those are the basics that we want. So maybe what we are going to do is let's do structures. Let's make sure that we're always on mute. Let's make sure that we're always on mute.
Say,
Yes,
Lawson,
yes,
um, so I have a question
yes.
on loops.
Mhm.
I see that you have initialized the sum with 0 when you're declaring in there. So does it mean if I just declare sum only without initializing, will it affect my program?
No, by default, if you just declare an integer value, it is going to be given the answer 0 as default. But I'm seeing here, it's actually not doing that. It's actually not doing that. Why? So I think it's very, very important. You need to initialize it. In other languages, it's very, very possible that when you declare an integer, the default value will be 0. But I'm seeing with the C programming, it's different. You need to initialize it with the 0. And that one alone is actually ensures you that whenever you get a wrong value, it will be easier for you to track where the error is coming from. Why? Because you know that initially there's a 0 there in sum. So you want to find the total sum. So basically you need to start where sum is equal to what? Is equal to 0. That's the initial step. So please initialize it with a 0 there. Declaring it alone is not going to put 0 in the sum there. So maybe it's just giving a default value that which is being given there. But you have seen that whenever I try to do it without declaring it, you are seeing the output or the result here. It's an awkward number that we are seeing there. So you need to make sure that you initialize it. Doesn't cost you anything. So you get the correct and the right result there.
It's
Thank
okay.
you.
Thank you, Sen.
Okay, thank you for your question. So now there's also something in our chat. Say we'll be able to get these slides later. Okay, the slides I'll give you, these are the slides that I've actually created when I wanted to do some videos for you so that I will like doing pre-recorded videos, put them on YouTube so that you could follow when you're doing readings. You see that there are a lot of long videos, so you maybe be trying to do something smaller so that you can actually just go there, see what you want to see, and then try the concept, something like that. So they do not have much information, but they're good. So they are just for me so that I will be explaining. So I just taking few moments on the slide and then much more on the demo, something like that. So those slides alone, they are not enough, but since we have actually covered this, so it's actually possible for you to be able to track what you do or what is happening. Okay. So now let's look at these structures in C programming. What are these structures? And maybe why do we need and why do we need them? Okay, so A structure is a user-defined data type that allows grouping variables of different types together. We have done arrays, and we have said in arrays, it's just a collection of variables of the same type. But now we are saying within now structures, this one is a user-defined data type. I'm going to explain user-defined data type that allows grouping of variables of different types together. So this one now comes in to help us, right? Whenever I want to store data of different types as a single unit, something like that, right? So now this one comes in handy now. Maybe you want to store a student in your system, right? Where student have got a name, have got an ID, have got age, and they've got maybe modules that student is doing. You want to store it as a single entity, or maybe just a single variable that whenever you access it, you can have all those things, something like that. Now that's when you can use these structures. You are no longer going to use arrays. Why? Because arrays will store the data of the same type. But with the structures now, you'll be able to group all those variables like ID, name, whatever, of different types as a single variable, something like that. Then the user defined now, it means that whenever you are going to create a structure, it is going to be user defined in the sense that it's not going to come as a built-in data type like int, that we know that in C program we've got an int. So maybe someone will decide to create a structure called the student. So it's user defined. You, the user, is the one who is going to define the name, or maybe the type of a structure, not the name. It's you who is going to define the type of your structure. Maybe you're going to have a structure of type student, or maybe a structure of type book, something like that. Maybe a structure of type person. So we call it user defined. Why? Because the user who is creating the program is the one who define the data type of that structure. So structures organize related information together logically. That's why we use them. Useful for representing real-world objects like a book, a car, a student, something like that. I've explained this. So that's the main important that we need these structures. So they make programs easier to read, maintain, as well as scaling them up. So for example, here on the syntax of declaring, normally it's just creating a structure. We use the struct keyword, and then you put the structure name like here, and then you put the variables inside, or the data members that you want to have under that structure. So if you are going to have maybe you can have maybe struct student, and then you have int maybe ID, or maybe int something like that, and then you can have maybe int age, or maybe int mark, whatever, something like that in here. And then that's where you are supposed to terminate, or that's where you're allowed to terminate after these curly brackets. You could say that even after an if or a while, whatever, you are not going to terminate. But for this one, please, you are supposed to actually terminate. All right. So for example, how do you declare structure like this one? It is showing you how you declare structure. You need to put the struct keyword, then you put the structure name, and then you put the data members or those variables that you need, like the row number, whatever, marks. And then this one will just define the structure type. That's why I'm saying it's like as good as creating it, but in the memory, it's not yet allocated. So how do you now use it? It's now that's when now it is going to be put in memory, like when you are declaring the variable. So you need to declare it later, like struct student S1, something like that. After defining, now you need to create the variables of that type. So instead of having int S1 or int num1 or int num, now we are going to have struct student. That's why we said this one is user defined data type. The data type is what? Is a student. Is that making sense? The data type is a student. It's no longer int. It's no longer car. Something like that. It's now stored. So that's how this user defined data type comes in. So we are going to have this S1, S2 is variables in memory, and each and every variable now have got the row number, the name, and the marks, these things that that this student already have, something like that. So maybe now is how can I access that? Now we are going to cover that in demo, how to access this. You use what you call, you can use what you call a dot operator, something like that. So let's try this out. Let's try this out. Structures, it have been a while since I code these structures. But normally when I declare structures, guys, the first thing, first things first, you not declaring, but creating a structure. You register it here at a global space, here at the top here, not inside here. You put them here, at the global space. After including whatever you want to include, the next thing is you put global variables here. Those variables that you want to be accessed by any function, by any whatever, anything within your code, you put it a global space at the top there before the main function. So that's where you also put the structure, and you need to use the struct keyword, right? Struct, and then you put the structure name, and you put these curly brackets, and it happens that this one, I've actually terminated this for me, so please do not forget this termination. All right, so what am I going to have here? Maybe I can have, let me just have simple things. Maybe I can have int age, right? Let me just put maybe 30, and let me put maybe the name, right? And normally for this one, because it's you need to put, because it's an array, so normally that's how you are supposed to do it. So let me say James. All right, it's an array, so of size 40, and I'm going to store this what or something like that. So this is what I have. Let me compare it, see if I do not have any errors. Okay, I have an error there. What's it? Attribute before. What could be the error here? What have I done there before attribute expected? What could be the issue there? What if I did wrong there? I am not seeing the error there. I am not seeing the error. I don't know, maybe I've done some. Yes.
I think is the comma after that closing bracket.
No, that one is supposed to be there. That was supposed
Okay.
to be there. That one is supposed to be there. I think the error normally is not clear here. The error normally is not clear. It's saying that error expected, like some sort of full colon, that one, or attribute before this token, before this initialization. Am I not? Okay. Maybe. So I'm supposed to declare, not to initialize, just to declare. Okay. I see where I made an error. Yes, I'm supposed to just declare, and then when you are now creating, why? Because here it's not yet given memory, so it have nowhere to store. So I'm supposed to just declare. As I've said, it have been long before I caught this, but at least I managed to pick it. Okay, and then after doing this, now I want to declare a variable of type student. So now I can say struct, then I need to write the name of the structure like student, then I can have maybe S1, right? So what it means now, I have this S1 with age and name, something like that. So maybe I can try to print this one, print F. Oh, no. I need to give this one some values as well. I need to give this one some values. Like if I say S1 dot, oh, okay. So if I say S1 dot, it's actually give me, do I need age or I need, so I need the name and I need to initialize the name with the gems there. Let me try it this way. Then I need to use S1 dot age. Maybe I need to put 30 there. Now let me print print f. So let me just now put this. Let me terminate here, and then I'll say name, right? Because it's name, it's a string. Let me put %s like this, and then I'll put here. Let me put a /n, and then let me put s dot name, something like this. So s1 dot name, something like this. Let me try to print the name. Let me compare this. I have an error. Assignment to an array. I have an error here for string initialization. If I'm using, what could be the error here? For these strings, for this, it's now the issue of working with the strings for those who are coding. Is it case sensitive? What could be the case? It's not the issue of case. It's not that issue, because here I'm using this name. So the issue is about having these double quotes on a.
Hello, sir.
Yes.
I pasted decision code there. I think that one is more simple. I know you can copy and paste it there on the chat section.
Okay, but we still need to. No, don't worry. The issue is very, very small. It's about the issue of strings in the C programming, where you are supposed to use the characters is a way of storing strings. So the issue is now on here where I'm initializing using the double quotes. Maybe I can have one thing from here, but I thought you as people who are actually coding more on this, oh, this one doesn't help me either. It wasn't initialized directly. But guys, let's go and look at this thing. It has been long, me coding C, but this one I'm sure it's very, very simple to look at. Okay, so maybe let me just try to just comment this out. Let me just work with edge here, and I'll look for it. But let me just go with edge here and see what I will get. I didn't want to use we have a class that we can use, or maybe it's because I didn't change this one to %d. I didn't want to use. I can just include the strings here. I can just include the strings, like here the strings library. I didn't want to use that. Okay, I was supposed to use okay, thank you for that. I was supposed to use those curly brackets to initialize, but somehow I used to do it. Okay, so I'm getting edge state there. I'm getting edge state. Okay, but I'm sure it's the other better way of doing it, which is not giving it the size. It's only that the issue mainly is because I've used I'm not supposed to keep on putting the size. But anyway, someone want to say something there? Pana ane mic irikiita inonzi ane mic iri on irikiita noise. Okay, let me try this and see if I'm going to get the result. No, I'm not going to get the result. So I'm supposed to repeat this one in brackets. But this one, I'm sure we can. I'm still getting an error. It's not going to work. I'm sure this one is not the correct way. Anyway, please go and look at this. I'm sure it's a very, very simple way of doing it. It's a very, very simple way of doing it. Of doing this. The other one is to use the string class, which is the one that I want to ignore. Why? Because when you are doing data structures, mostly they want you to avoid to use that class library. So sorry for that. I didn't look into it before, but you can just go and look into it. It's not a big issue there. So maybe now what we need to look at, now we have actually able to access this age, and we have been able to access, also you can access this name, but it's only that it's empty. We didn't able to initialize it here. Maybe let me just go the easiest way here. Initialize, maybe initialize C string array, maybe using car, maybe this way. We want to use the car. So the best way, yes. So it was supposed to work this way. It was supposed to work this way. Or maybe the somewhere where we missed it. It was supposed to work that way. Or this one, they're actually using this string, but we do not want to use the string. So it was supposed to work that way. I don't know what could be the issue, but mostly it was supposed to work this way, where you can just initialize it. So I don't know what went wrong. Like here, it was supposed to just work if I put this here. It was supposed to work, but I'm going to get needs what expected expression before this one. Maybe if I put the size there, but it was supposed to just work. So I will look into it. Why is it not working? So I need to compare this. So it's saying assignment to car from caster makes integer from pointer without a case conversion, whatever there. But mostly it was supposed to work. I don't know what could be the issues with my compiler, but I've actually done this before. It can work. You can. Okay. I think we need to use. Yes, something is now starting to popping up. You need to use the pointer there. I think I saw something. This one, the star there. Yes. I'm sure that's the issue that I'm missing here. I need to use this star here. This is star, this one, the asterisk. You use this one. Yes, I'm sure with that one, this one should compile very well without any issue there. I'm still having any issue. This one should compare. So that's how you debug. That's how you debug code. You need to look at these things. Let me see. Maybe now it's compiling. Let me see if I can put a name here and the percentage S. So sometimes it's a name, something like this. Let me compile. Let me run this. Compile and run. I'm not getting the actual output that I was expecting. That's what I'm not expecting. But this one is actually giving the output correctly. Why not mine? Why not mine?
Say,
Yes.
I think maybe like mkatasa kumsoro arpama examples are not declare my characters kumsoro. Are not
This
declare
size.
eh. Are not declare kuno struct student are not declare kumsoro after I include after the head my headers. I think for my examples.
Yes. For that one we can agree. For that one we can agree. But somehow, it was supposed to work. Somehow, it was supposed to work.
Okay.
Yes, because this one now it's somehow it was supposed to work. Let me just leave it here so that we proceed. But please go and look at this. Sometimes it happens. Maybe it could be the library, or maybe it could be okay. So I need to, if I'm using a point, I need to remove this, the issue of size. Yes. Then it worked very well. Okay. I still remember explaining this in a certain video that I've done before, but because I've coded, I always code a lot of things. You see me doing Java, you see me doing C++, you see me doing C program, you see me doing web programming, whatever, JavaScript, whatever, PHP, something like that. So some of the things will just fade away, just because it have been a time since we've been caught that. But anyway, there's this fix. If you declare it as a pointer there, then you'll be good to go. Everything will work perfectly for you. So this one, if actually worked, I got it from Tawanda. I got it from Tawanda, and it actually worked. So let's now look at now we've managed to print this name, so you can also print this edge. Also, it means you can also change whenever you want to change. So by just doing this, something like that, by just doing this. So normally that's how you use structures. Also, you can have an array of structures. Maybe you can just make sure that you are muted, or let me just help you myself by muting you all. Okay. So basically that's how you use arrays, not arrays. That's how you use structures. That's how you use structures to put the data, the related data together. So that's how you do it. You declare it here, and then here you create. So you can have many students. You can have this S1, you can have S2 as well. And then you do here, when you're saying S1, James, now you can say S2 dot, you put the name, maybe the Tanaka or something like that. And then you print them just like that. I think it makes sense there. So that's how you create these structures of student type, something like that. So you can also do it having maybe a student which is or you can have these ones now as an what do you call it, as an array. You can have also have this one as a what, as an array, where you can store a list of students, right? So instead of just having one student, now you'll be having more students within that array. So we are going to look at this one when you are doing the basic questions that I have. I've put maybe just a very few questions in this document where you can actually try to solve these basic questions. So maybe you can start by looking at this one. Maybe let me just accept someone here. So these ones are going to help you maybe when you are revising. so that you could understand or you could get what you are supposed to do. Like this one, it says write a program, a C program to store 5 numbers in an array and find their sum. Oh, this one I've covered it. Right? This one I've covered it, right? When you're doing some examples, I think this one I've already covered it. To store 5 numbers in an array and find its sum. I've done that. I'm sure you can confirm with me. Anyone who needs help on this one, I don't think you can. Maybe we can save much of our time. It's now 3:09. Okay, so if silence means that we are okay, we've covered this. And then this will write a structure that defines a structure for storing student details, name, age, marks, and display them. Yes. Yes, you can say whatever you want to say. Hello?
Yes, I have a question on structures. What about if it's in an exam, then I use the string library, won't I get marks for that?
You get marks for them. You get marks for that. Don't worry, you get marks for that. I was just trying to say, if you go the hard way now, it will become easier for you to use or to understand these things. Why? Because you'll be asked to research more. I don't know if you're getting what I'm trying to say here. I know it's very, very easier to work with the string class. That's the reason why it was created. Why? Because it was actually more difficult for people to understand those basic things. But I'm just saying, try it, use it, and then you'll be good to go when you're just adjusting to other languages and adjusting to these things, something like that. So don't worry, you're going to get your marks by doing so. But it's something that I always try to avoid, so that I always keeping those basics on my fingertips. Okay, so any question? I think I've clarified your issue. Any question? If there are no questions for this one, I'm just feeling that we've covered it. Structure for storing student details, name, age, marks, and display. It's just as good as what we are doing here. Maybe the thing which is not here, maybe it's just about float marks, where you now need maybe to just store the student marks here. You can actually ask the user to enter those, or you can just something like that. So you can ask the user to enter, please enter your name, enter your age, what, enter your mark, and then you just print them. So how do you display? You need to have the printf for name, and then for age, and then for mark, something like that, and then you print out. Just as simple as that. So that's how you do it, and I think I have that code here for doing that. This is the best thing to do, like what I've done there. Then you ask the user to enter, and then you print. Maybe now to find the largest number of 3 entered numbers by the user, like this one, which says find the largest of the 3 numbers entered by the user. Like maybe the user is going to enter maybe 3 numbers, and then you are now going to check which one is going to be the largest number. So maybe the best thing to note here is that you need to actually, I think the best way to answer these problems is very, very simple. You need to first understand what you are supposed to do. You need to, or these numbers needs to be entered by the user. So you need to ask the user to enter the 3 numbers. So you can ask the user to enter the 3 numbers separated by a space, or you can ask the user to enter the first number, the second number, and then the third number. And then now you need to calculate, or you need to find which one is the larger number there, right? Something like that. So this is the best way that you can do it. This one, let me just copy this one. I've already a pre-compiled code so that we can save our time. And let's try to have it here. I hope it's not going to give me some issues. So the first thing is to declare variables, these first 3 variables. And then we have got this largest thing, we are going to use it to store the largest number whenever we feel that this one is going to be the largest number. And then we say enter 3 numbers separated by spaces, just like this. And then so it is allowed to take maybe more than one value at a time from the keyboard. Just need to put scanf with these format specifiers, and then so which means the first number is going to be put in A, the second is going to be put in B, the third is going to be put in a C, something like that. And then when you execute this, obvious, it is going to start by taking those 3 numbers, and after that it will assume that A is the largest, so we store the value of A as the largest in the largest, right? So what to do now, we compare B with largest, which is we are comparing B, which is the value of B that we've entered, with the value of A. Why? Because currently in largest we've got an A. So if B is greater than the largest, which means if B is greater than A, so we assume that B is the largest. Why? Because it is greater than A. And then the next thing we need to compare C with the value of B, right? So you compare C is it greater than B. So if B is greater than A and C is greater than B, it means C is the largest. So we store largest in C. So what happens is, if B is not greater than C, is not greater than A, it means A is the largest. So largest, we remain with the value of A in largest. And we compare, is it C greater than A? If it is C greater than 8, so we are going to store C in like something like that. So we'll be done with comparing those 3 values, just as simple as that. And then we'll print the largest number, which is in which is actually going to be, that value is going to be in largest. Then we are good to go, something like that. So we can compare and run this. What could be the error there? Only implicit I'm having this error. Okay, maybe I needed to put the hash include how do you call it, stdio.h. This one is the missing, it's the first missing thing there, and then it can compare and run something like that. So enter 3 numbers, so I'm going to put in a 2, and then I'm going to put a 3, and I'm going to put a 5, and I'm going to get the largest number is 5, just like that. So basically, that's how you can do it. So it's very, very simple, very, very easy, but maybe it's now the way you try to solve these issues. I don't know if I've got a question on this. Otherwise, I would proceed to the last one, which was asking to accept details of 5 students and display the student with the highest mark. This one now is asking you to take 5 students. So I have said before that you can create an array or a structure, an array of a structure, something like that. So this is where you can make use of that. So here you are supposed to take, maybe you can have here, the main thing here is, let's look at this question. Maybe there's something that I'm not taking here seriously. Say, symbol that defines a structure student with the members. Here, guys, you are being given members. The members are name, ID, and marks. So we need to see them within your structure, the name, the ID, and the marks. But now we need also to have, at the end, we need to have the student with highest mark, something like that. So first things first, what are you supposed to do? What are you supposed to do? You need to first declare the structure. And let me just take this. Maybe if I take this to the IDE, then it will be better that way. It will be better that way. Let me have it here. So first things first, this is what we check. You are asked to have this. And then the next thing here, you can also have the array of 5. This one is the best simple way to do it, of having an array of a structure. What it means is that we are going to have an array which is going to hold 5 students. So at index 0, we'll be having the first student. At index 2, at index 1, we are going to have the second student. So at index 0, we are going to have a structure with all these things. At index 1, we are going to have a structure with all these things, something like that. I don't know if it is making sense. So let me just compare this and make sure that I do not have an error. Okay, sorry, I removed some or this one. I'm supposed to have a struct keyword there when you're declaring it. I'm sure that's the only error that's there. Okay, so everything compiled very well. So if you look at it, here now you need to input the details for 5 students using a for loop. Imagine if you didn't use an array here, it means you are supposed to declare maybe something like student info. Why? Because the structure is called student info. So maybe here you'll be supposed to say, instead of having this, you need to have maybe S1, S2, S3, S4, S5. And you are supposed to ask the user to enter the first, the name, the ID, and what for S1, and you accept that. You do again, you write a code again, maybe after this, you repeat this same code now, the same code, this one, but now using the using the second student, which is S2. You do this whole code again using S3, something like that. So to avoid this, now we need to use this array. So what it means is that we have this students array, which is going to hold 5 students, and these 5 students are going to be of type student info. So each and every student is going to have all these things, something like that. And then because we want to find the highest mark, then that's why we need this highest index there. So this int I normally is just there so that here we are not going to declare it. So here when we have I is equal to I plus 1, we can just have this one. Basically, I just wrote this thing. I'm going to code it from zero so that you could understand what I is equal to I plus. It's just as good as I plus plus. You can just put an I plus plus there, no problem. It will work super easy there. All right. So here, what we are going to do is, because we need to store the details of the 5 students, and we need to start our I at 0. Why? Because the index runs from 0 up to size -1, and the size is 5 minus 1. So it's 5. So 5 minus 1 is up to 4. That's why we've got I less than 5. Whenever we reach 4 here, 4 less than 5, yes, but 5 less than 5, no. So you know that is. So here, if you are using less than or equal to, here you need to adjust and put a 4. Something like that. Otherwise, if you are just using less than, you can just put a 5 there, then you are good to go. So the first thing is going to ask me enter details for student %d, then I put I plus 1. So this one is going to say enter details for student 1, something like that. Why? Because at first I is equal to 0. So it is going to be 1 I plus 1, which is going to be a 1. So when I'm storing students at index 0, so at first I will be 0, at index 0, so I'll be asking the student to, not the user to put the details for student 1. That's why I've got an I plus 1 here, something like that. And then here, you do not put some space. Why? Because if you put some space there, so maybe this is what I was supposed to do with my, okay, I wasn't using scanf. I was just trying to put the data direct into this this one. I know it should work. I'm going to look at it. So basically, this is how you you would take the value from the user using %s there. This one %49, it's just because we are going to have an array of 50 characters, which is going to be from 0 up to 49 as the index, something like that. So after that, we store the value in student I's name. So that's not one that's good. Can trip index 0, which means at the first index 0, we are going to store the name, and then we are going to store the ID, and we are going to store the marks, and then we go to item, we go to index 1 less than 5, yes. So now we store the student number 2 at index 1. So at index 1 we put name, we put ID, we put mark, something like that. You go up to index 4, which is the 5th student. So at index 4 we put those details, something like that. We put those details, and then now we need to find the highest. So how do you do it? Now finding the highest mark is no longer, like, there's no need of looking at name or the ID. The interesting is now marks. So how do you do that? Now you need to look for the index that you've got higher marks, so that you can use that index to get the name of that student, the ID of that student, and maybe the mark as well, something like that. So that's what you need to do there. So how do you do that? It's as good as now we want to find the highest number in a given array, something like that. Take it as just like that. So you take for index from 1 up to less than or equal to 5. Here I can put I++ just to make it easier for you. Let me just put I++ to make it easier for you. So here I'm going to start at index 1 for one good reason. I'm going to start at index 1 for one good reason. If you want to compare things, just market data structures where you'll be doing my sorting algorithm, something like that. If you want to find the greatest within an array, obviously you want to compare uh, things at different boxes or at different indexes, right? So you want to compare maybe something behind with the next thing. So something at index 0 and something at index 1, which was greater than the other, right? So we want to keep the index with the highest number until we reach the end of the array, something like that. So maybe you compare the first and the second. If the second is greater than the first one, so we just take maybe that one as the index with the highest mark. We go and compare maybe the next with the something like that. Was if the second is greater than the first one, it's obvious there's no chance that the first one is going to be the index to the high. So we just move the highest index to the next. Then we compare maybe the third with the second, something like that. And we compare maybe the second with the third one. So with the fourth one, if the third is not greater than the second or something like that, until we reach the end of the array. So here we are going to first compare. I is going to start at 1, but here we are going to put in highest index. And if you look at it, highest index is here is 0, right? So it's as good as we are going to compare the mark of the first student and the mark of this the mark of this first student, which is because here we've got a 0 and we've got a 1, and the mark of the second student. So if the mark of the second student is greater than the mark of the first student, so we know that index I, which is 1 here, because initially I is equals to 1. So the second student, or the index of the second student, is the one that have got highest mark. So we store it here, right? And then we increment I by 1. So we have 2. So now we compare the student at index 2, which is the third student, mark with the first student. Why? Because the highest index now is equal to 1, because we have already changed the value and put an I, right? And then if this one is greater than this one, it means we are going to store I in this one, which means I is what? Is 2, right? So something like that. And then you increment this one maybe to 3. So you're going to take the fourth student's mark, compare it with the third student's mark until you reach the end of the what? Of the array, and you would have now in highest index the index of the student with the highest mark. And what do you need to do now? In print the student at the highest index, and then you take name, you take ID, you take marks, and then you print it just like that. So if I compile and run this, maybe it's going to take me longer to do this. So the name of student one, let me just put Jane there. And then the ID, let me just put 1 for ID. And then for marks, let me put 20. And let me put James. And then I'll put ID as 2. And then maybe let me put the marks as maybe 30. And then enter the details for student 3. Let me put Jake there. And then let me put the ID is what is 3, and then let me put the marks maybe as 40, and then let me put the 4th student. So the name I can put here, memory. Maybe I can say 4 ID, and then the marks maybe I can put 79, and then the 5th student now. So I'm going to put maybe a 10 for the for the 5th student. And when I we know that memory is going to have the highest mark, so here I'm going to put a 5, and then I'm going to put a 10 here. So let's see what I'm going to get. So I get the top scoring student. So I got memory and ID number and the marks, just a simple start. So zvinoita sezvakaoma, but if you try to follow code more, you get to understand what you are doing. So that's how you can answer that question. So basically, so you're supposed to accept the details and display the student with the highest mark, something like that. So this is how you can answer such questions. So you can go and try to play around these questions, try to find a way on actually answering these questions, and try them as many times you can, it to actually polish your coding skills and your coding style. So that's the end of my presentation. Maybe now is the time that you would take questions, or maybe it's the time that you would take some maybe some contributions. And to do so, you can just raise your hand. And maybe let me just also stop my recording so that we do our question and answering. Okay, now we've stopped the recording. So